September's cosmic wonders, asteroids, eclipses, and exploding stars. September has been an extraordinary month packed with thrilling space events that have kept astronomers and stargazers on the edge of their seats, and it's far from over. The month kicked off with a shocking discovery. Asteroid 2024 RW1 was spotted at the last possible moment, raising serious questions about the strength and reliability of our planetary defense systems. With a size of around 15 meters, this asteroid's sudden appearance serves as a stark reminder of the multitude of space rocks lurking in our solar system, waiting to be detected before it's too late. Thankfully, this small asteroid posed no immediate threat to Earth. However, another space rock identified nearly at the last minute could have caused significant damage had it collided with our planet. Yes, we're talking about an asteroid detected in August 2024 that made a close approach to Earth in mid-September. Fortunately, this asteroid safely zipped past us on September 17th, coming within approximately 1 million kilometers, around 2.6 times the distance between Earth and the Moon. If that's not enough to keep your eyes on the sky, September also gifted us a breathtaking celestial event, a supermoon lunar eclipse on September 18th. And 2 weeks later, on October 2nd, we can look forward to an annular solar eclipse, visible along a narrow path from the Pacific Ocean to the Atlantic Ocean, passing over places like Easter Island and southern Argentina. But hold on, September has a couple more exciting surprises to share. First up, Earth is getting a new moon that will stick around for a couple of months. Welcome to territory space. Enter the Arjuna asteroids, a specific group of near-Earth asteroids, NEOs, that are part of the larger population of asteroids in our solar system. These asteroids range in size from small boulders to larger rocky bodies, with some having orbits that bring them close to Earth. Sometimes, these asteroids approach so closely that they get captured by Earth's gravity, becoming what we refer to as temporary moons or mini-moons. This month, Earth is set to capture one of these mini-moons, a tiny asteroid named 2024 PT5. During routine monitoring of possibly hazardous space rocks on August 7th, researchers at the Asteroid Terrestrial Impact Last Alert System, ATLAS, detected this asteroid. Unlike our moon, which has orbited Earth for about 4 billion years, asteroid 2024 PT5 is much smaller, about the size of a bus, measuring roughly 10 meters in length. This space rock is expected to follow a horseshoe-like orbit around Earth rather than a full rotation, beginning its 57-day orbit on September 29th and concluding on November 25th. After that, it will return to the Arjuna belt and is anticipated to revisit Earth's orbit in 2055. The million-dollar question is there any chance of this asteroid hitting Earth? According to astrophysics professor Adam Frank from the University of Rochester, there's no need to worry. He explains that this asteroid is essentially a flying mountain in space that typically orbits close to Earth, and it's being captured by Earth's gravity to temporarily join the Earth-Moon system. He added, it'll orbit Earth for about 2 months, and then it'll get flung back out. So, we get a tiny little moon for a couple of months. He reassures us that if something this size were to hit our planet, it would be catastrophic. Here's an interesting tidbit. Asteroid 2024 PT5 might actually be a fragment of Earth's moon, as its motion suggests it could be debris from an impact on the moon, according to Paul Chodas, the director of NASA's Center for Near-Earth Object Studies. Unfortunately, we won't be able to see this mini-moon with the naked eye since it's quite small, and tracking it will likely require professional telescopes. Make sure to subscribe to Territory Space for ongoing updates. Now on to our next celestial spectacle. By 600 BCE, the pyramids of Giza had already stood for over 2,000 years, silently witnessing the rapid and diverse rise of human civilization. It was during this era that our fascination with the stars began to evolve into a systematic study. The Babylonians recorded the movements of celestial bodies such as the sun, moon, and planets, even developing a calendar to predict lunar and solar eclipses. Meanwhile, the Greeks challenged myths, proposing that Earth was spherical based on observations like the shape of Earth's shadow on the moon during eclipses. As astronomy began to take shape, a star 26,000 light-years away erupted in a dramatic explosion. Now, 26,000 years later, we have the opportunity to witness that explosion in our night sky. Imagine looking up and seeing a bright new star where there was none before. This was the experience of Burckhardt, the abbot of Erzberg in Germany, over 800 years ago when he observed a faint star that briefly shone with remarkable intensity. The star he saw was T Corona Borealis, a variable star located in the constellation Corona Borealis, also known as the Northern Crown. A variable star is one that changes brightness from our perspective on Earth over time. T Corona Borealis is located 26,000 light-years away, which means that the events we are witnessing today actually occurred 26,000 years ago. During the prime of their existence, most stars are fueled by nuclear fusion reactions deep within their cores. However, T Corona Borealis has advanced into its later stages, becoming a stellar remnant known as a white dwarf. But this white dwarf is not alone. It forms a rare and fascinating binary star system, locked in a cosmic dance with its companion star. The primary star is the white dwarf, a remnant of a massive star that has exhausted its nuclear fuel and collapsed into a dense object roughly the size of Earth. Although seemingly dormant, this white dwarf exerts a strong gravitational pull, drawing in material from its companion star, a red giant. The red giant is an older star, bloated and cooler, shedding its outer layers as it approaches the end of its life. This transfer of mass is critical to understanding why T Corona Borealis is classified as a recurrent nova. You might be wondering, does that mean it explodes repeatedly? Yes, around every 80 years, T Corona Borealis puts on a spectacular show for observers on Earth. As the white dwarf draws material from the red giant, it gradually accumulates it on its surface. Over decades, this buildup leads to the accumulation of a critical mass of hydrogen. Once sufficient hydrogen collects, a powerful thermonuclear reaction ignites, resulting in a runaway fusion event that causes the star to explode dramatically. When this occurs, the energy released makes T Corona Borealis shine 1,500 times brighter than usual, making it visible to the naked eye in our night sky. The last eruption occurred back in 1946, and as we approach the 80-year mark once again, astronomers eagerly anticipate the next explosion. When T Corona Borealis goes nova, the released energy blasts the accumulated material into space at incredible speeds, creating an expanding shell of gas. The system becomes one of the brightest objects in the sky for a short time. After the explosion settles, the cycle begins anew, with the white dwarf continuing to draw in material and preparing for the next eruption. So how do we know we are on the brink of witnessing another explosion? T Corona Borealis' previous two eruptions, in 1866 and 1946, followed similar patterns. About a decade before each explosion, the star's brightness increased slightly, reaching a state known as high brightness, followed by a brief dimming about a year prior to the nova. The star entered its high brightness state in 2015, with the first signs of pre-eruption activity detected in March 2023, putting astronomers on high alert. The reasons behind these patterns remain one of the intriguing mysteries surrounding T Corona Borealis. But don't wait too long to see it. Once T Corona Borealis erupts, its peak brightness will be short-lived, lasting only a few hours before it dims significantly within a week. Observing it will likely require binoculars or a small telescope after the initial brightness fades, making it a unique opportunity for amateur astronomers to spot the eruption and alert the professional community. During its peak brightness, the nova will be visible to the naked eye, but avid star watchers equipped with binoculars or telescopes will enjoy a more detailed view. While it may not rival the brightness of the most intense stars or planets, this nova will undoubtedly be a remarkable and memorable sight, marking a once-in-a-lifetime cosmic event. So be sure to look up at the night sky